This is the Enterprise IT checklist for Docker operations. Our speaker today is Nico Kabar. He is a solutions architect for Docker and tweets at Nicola Kabar.
Thanks, Ben. Hello, everyone. How are you guys doing today? Good? Awesome. So my name is Nico. I'm a solution architect at Docker. And I get the privilege day in, day out for the past 2 years to work with enterprise customers like yourselves. And I see many of you guys I worked with over the past couple of years. I work with customers to design and architect Docker solutions. And over the last couple of years, I kind of learned a lot by working with you and with the rest of the enterprise customers. And working with the enterprise customers, I learned a lot of their requirements, their patterns, what their goals are when they kind of develop, design, and build Docker solutions. So I want to share a couple things to start with. A common number one goal I see with enterprise customers is to deliver value to customers fast. And here we're talking about internal customers that are different development teams, testing teams, QA teams internally, and by extension, the external customers for your enterprise. This is truly what is becoming a true differentiator for you amongst your competition. It's really setting you apart. So amongst all the customers that I work with, IT and delivering IT solutions, delivering that application, taking that application to production, is truly what's setting you apart. What's truly what making you different than the other enterprises that compete against you. Also, over the last couple of years, I am spending less and less time trying to convince or kind of trying to promote Docker itself. A lot of you guys are here because you believe in Docker. You understand the value of Docker. There's not a lot of need to kind of promote Docker or try to convince you why Docker. But not only that, a lot of the customers I work with truly believe that Docker is not just it's just not a tool. It's actually at the center of achieving that goal that I talked about. It's really important to get them there, to differentiate, to deliver your software. Now comes a challenge. The biggest challenge is moving to production in time to prove the value of the solution that you're working on. If we have all the time that we need, we're probably going to prove that value. But what's really needed is to kind of deliver the solutions, take the application to production in time, and securely, and have the successful deployment in time to prove to your kind of leadership that this solution is actually what it's meant to do, and this is truly what differentiates you. So by working with those customers, we realize that this is kind of truly is a big challenge, right? It's not easy to take a Dockerized solution, build a Docker platform, and take your applications to production. That's one common pattern that I'm seeing with many types of customers coming from financial, healthcare, small and large customers aside, they're all having those sorts of challenges. So to address that challenge, we learned a lot of lessons, right? And my group at Docker, the customer success group, is trying to kind of make sure that we share those lessons, so you don't have to go through the same challenges again and again. And today, I'm going to walk you through a Docker production readiness checklist for enterprise IT. The main focus is going to be Docker EE, but again, this also pertains to Docker overall. This is kind of the checklist items that we're going to go through. It's going to go from infrastructure to orchestration management, image distribution, security, networking, storage, logging and monitoring, integration, disaster recovery, and testing. This is not going to be an all-exhaustive list, but this is a good start. Those are good areas to kind of put in front of you as you're designing the Docker platform and kind of truly continue focusing on making sure that you're addressing each of them so that you have a smooth transition and a smooth move to production. If you want to follow along, you can go prepare the checklist also for you here, so you can actually follow along, but I'm going to take you in slide mode right now. So let's talk about infrastructure first. Typically, again, this is beyond the. This is when we start planning for the actual platform, right? This is beyond the customer already understands what Docker is. They see the value of Docker. They're trying now. We're in planning phase. They could possibly have already Dockerized a traditional application, an existing application. They're working on a microservices-based application, and now they want to take those applications and put them on the Docker platform and take them to production. So based on the application profiles, right, cluster sizing and zoning, where do you put your infrastructure, whether it's on-prem or in the cloud, virtualized, non-virtualized. We have those kind of discussions, but then they come based on your requirements, based on the enterprise requirements. You come to decision that this is the best place to kind of place that cluster, and you're going to start with a number of nodes. The second item is to make sure that it's supported and compatible stack. We have a supported list of OSs, Docker engines, UCP, and DTR. You need to make sure that you have the compatible versions along the full stack, right? All the way from the OS all the way to the applications. Host sizing, that's the kind of number one question that we see is like, how big should be my VMs or my instances or my hosts? Our minimum recommendation from a manager node is 16 gig of memory, 4 vCPUs, 1 gigabits per second of networking, 32 plus for disk. For worker nodes, it truly depends on what applications you're going to be deploying, right? So at the minimum, you're going to have at least 4 gigs memory, 2 CPUs, 100 megs per second for networking, and 8 gigabytes for disk. But it all depends on the application you're going to be deploying on the cluster. So it's important to profile how the application, if it's an existing application, profile it as it is today, right? And it's going to be pretty much the same when you move it to Docker. This is how you can size your cluster. If you move to the orchestration management, this is Swarm and UCP. All the customers I work with have a highly available UCP cluster. That means that you're going to have 3, 5, 7 managers, right? You need to, in order to maintain quorum, you need to have an odd number of managers, right? So you can have 3, 5, or 7. Pretty much the only thing that you get by going from 3 to 5 or from 5 to 7 is a number of nodes that you can the number of nodes that even if they go down, you can still withstand having the cluster running. So with 3, you can have 1 going down at any given time. For 5, you can have up to 2. For 7, 3, and so on. If you have multiple zones, or you're deploying on Azure or AWS, and you have this concept of zoning, right? Make sure that you span your managers across all zones, right? There are networking requirements that we'll talk about them, but overall, make sure that at any given time, only the allowed number of managers can be out due to a failure or a DC going down. You can spread them across 1, 1, 1 or 2, 2, 1, depending on the number of managers and the number of availability zones, as long as you kind of take that into consideration. Another recommendation is we usually do fine-tuning for the orchestration settings. Things like task history limit. So how many containers at any given time the Swarm kind of keeps after they exit. They keep them still on the engine. So that's a good setting to kind of tweak before you actually deploy your application. It's a global setting, so those are all global settings for the orchestration as a whole system. There are REST settings and node certificate rotation. They're also things that we worry about and we talk about with customers in terms of tweaking before you take any application and put it on UCP. Upstream TCP load balancers, a lot of times customers end up putting terminate SSL upstream, which means it's going to break UCP. You need to make sure that you use other hardware-based, like a F5 load balancer upstream, or software-based Nginx, HAProxy to do a TCP load balancing. Very straightforward load balancing. So that way we can terminate SSL at UCP. There's a great setting in UCP that allows you to not allow anyone to deploy any application workloads on the managers. And this is not really because of resource contention. This is more of an isolation between the cluster management layer and the application workload layer. So by setting that by enabling that, make sure that regardless of which, all the teams, all the members within your UCP cluster cannot deploy anything to manage your nodes. And finally, as a huge recommendation that we definitely recommend to our customers to have is always think about labels as way they can identify the resources. All orchestrations out there, whether we're talking about Swarm or Kubernetes, they use labels, right, for RBAC purposes, for querying and kind of viewing the resources that you're available to use. So it's really important to identify and label accordingly all the resources. We're talking about networks, volumes, containers, services, secrets, nodes, and all the Kubernetes resources in the future. Let's talk about image distribution. Similar to UCP, you need to have a redundant or highly available DTR infrastructure 3, 5, and 7. Very similar to UCP in architecture. You need to make sure that because of this, you have 3 instances of DTR. The DTR is where you hold your images. You need to have a shared storage across those instances. That means that you need to use an external, either file-based or object-based storage backend, like NFS, S3, Azure Storage, Google Storage, and so on, to provide this shared storage for DTR. You need to make sure that's well configured, replicated, and secured. Great feature of DTR that a lot of customers use to reduce the cost of the above mentioned storage used is garbage collection. Just remember that when you remove any images from the registry, right, the only thing that you're doing is dereferencing the tag from the blobs, right? So garbage collection kind of takes the next step, which is looks at all the unreferenced tags and deletes them from disk. So deleting any image is a 2-step process. 1, you need to delete them through an API call or from the UI. And 2, you need to run garbage collection, which runs like a cron job that's set in DTR and kind of goes through that list and deletes them. So it's really important to set it up. Finally, make sure that you have enabled security scanning. A lot of our customers end up deploying code that isn't supposed to be deployed or has any vulnerabilities, so make sure that you enable that setting. Let's talk about security for a bit. This is not an exhaustive list. This is just a tip of the spear when it comes to all these areas. I just wanted to cover as much lessons learned over the past couple of years working with enterprise customers. Utilize the Docker EE RBAC model. There's a talk, I believe, tomorrow from my colleague that goes, does a deep dive into the new model. The new model is really granular, that provides users or subjects, grants them roles so that they can access certain collections of resources. Here we're talking about resources like networks, networks, nodes, services, secrets, and all types of resources that you have across your cluster. It's at the API level. So you give API level permissions to team members that you define, and you connect to your AD or LDAP. So that's kind of brings me to the next topic here. Make sure that if you have an onboarding process, offboarding process for new users in your teams, it makes it a lot easier if you have AD or LDAP integrated, because you can map those groups. You can map teams within Docker EE to those AD groups, and then you can apply permissions at the team level. So it's really neat. So if you have anyone joining the team, someone leaving the team, all that is very, it's a smooth process. Docker Content Trust signing and enforcement. So you have the signing process in DTR. This is where DTR holds the trust metadata, and UCP enforces that policy. So ensure that you have those kind of configured both from a DTR perspective as well as from a UCP perspective. Finally, anyone heard of Docker Security Bench? Great. So for those of you who have not heard about it, it's a great tool that uses the CIS security best practices and runs through the host and provide you some information of warnings and recommendations on what you should be changing at the individual Docker environment. So with every release or whenever you change your environment, it's a good practice to go ahead and run this security tool. Let's continue on with some more security stuff. All the stuff that we talked about, the RBAC model that we have, all of that is useless if you give users direct access to the hosts. Because as soon as you give them SSH or RDP access, they have access to the Docker socket. That means that all the upstream rules and permission policies are gone, right? Because they can talk directly to Docker. So one of the benefits of using the end-to-end Docker EE is that you don't have to give anyone access to the system, right? You only onboard them to the system, to the platform, and you don't have to give them SSH access, right? They can see the logs of their containers, they can deploy their containers without stepping on each other's toes. So that's really good to remember. Utilize the built-in secrets functionalities, right? You guys know there's definitely multiple talks about secrets and how we do them across Linux and Windows. They're really neat, especially for sensitive data for your applications. They're encrypted and controlled. So make sure that your application, whenever you see your applications kind of built not using secret, try to kind of embed those in there. A lot of people also do, they orchestrate the swarm joins or kind of the bring up of the cluster using keys. So you get a join token that kind of identifies the cluster, and you do Docker swarm join, and you use that token. And that's a lot of time that gets copied and pasted in some config management. So when you bootstrap the cluster, it's left there. One problem that if that gets compromised, that means that some rogue units out there can be using that to join your cluster. So make sure that you have a good practice around rotating those keys frequently. That way, older keys can no longer be, or older tokens can no longer be used to join the clusters. Not a lot of people know this, but as an enterprise IT, a lot of you have an internal CA. How many people have like an internal CA that you use? Good number of you. So Docker EE does allow you to use your own CA to establish mutual TLS across the cluster. That's for node identity and all the communication, management communication, control for networking within the cluster. So you can, as long as your CA does use CFSSL as a protocol for handling CSRs, then you can use your own CA. Aside from that, make sure that you also have a valid SSL TLS certificate for UCP and DTR for external access. So when you're accessing UCP and accessing DTR, make sure that you generate certificates for DTR and UCP. Let's talk about networking, my favorite topic. So pick the right networking driver for your application. You have a couple of options. We ship with a couple of options, batteries included. Depending on your application, really I can't recommend one driver versus another, but it really depends on the application. For applications that don't need any external traffic to be hitting them, they don't need anything to access them, especially if they're microservice-based application, overlay networks is really good for east-west traffic, right? You don't have to worry about service discovery. You get a lot out of the box with overlays. If you need to have some access for your application, or if you're using existing kind of registration or service discovery mechanism, you can use the bridge and host port mapping that everyone is familiar with. Select the proper publishing mode. So if you want to publish your application externally, we have two modes available. Ingress, that's kind of uses the routing mesh functionality that we released with last year. We also added host mode, which basically allows you to orchestrate your applications, stack deploy your applications, take the best of kind of the orchestration functionality, but at the end of the day, only use kind of the bridge and host port mapping wherever that service task lands. So it's pretty neat mode for publishing external services. Pick a suitable load balancing mode, right? So depending on your applications, if your application can do and would prefer doing client-side load balancing, then use DNSRR. This is how you publish an application. This is how you set an application to be resolvable using a set of the IP addresses for its containers. So whenever you do a DNS query against that application that goes into that mode, you get back a list of all the healthy containers, right? That way you can do client-side load balancing, you can do client-side health checking, and so forth. If it's a stateless application and does not worry about session stickiness and so forth, you can do VIP, right? The VIP, you only get, the service resolved to a single virtual IP, and that IP fronts the healthy containers that define that service. So you only have one IP that stays there for the length of the application lifecycle, and you only use that one IP. And as containers go up or down, you don't worry about that. You just talk to that one IP. For network latency, we recommend across all the nodes, especially the manager nodes, to have them less than 100 milliseconds. Usually, if it's within your data center, we're talking about 10 to 20 milliseconds. However, a lot of times, customers I work with, although they say they understand, how much latency there is between their nodes, they don't have a full understanding. They're not monitoring across, within a longer time frame if they have any spikes, right? If there are any spikes with network latency, that means there could be the quorum could be lost and you can have some issues. So make sure that you're monitoring your network. Make sure that you put the managers as close to each other as possible, and make sure that you're always aware of what's going on with your network. That way, if anything goes wrong, you have an understanding of if it is network related or not before you start blaming networking. If we continue on networking, segment your application at layer 3. With overlays. So we recommend one application per overlay. This is how we provide a security mechanism, even within the networking. Within networking, we provide segmentation at layer 3. Not only we're doing it at layer 3 from a data path perspective, we're also doing it from a service discovery DNS perspective. So everything is network scoped. That way, if you put your application services within one overlay network, the services can talk to each other, they can resolve each other, and no one else can access them. You utilize the built-in encrypted overlay features that you saw this morning. Not a lot of people know about it. I know a lot of customers love the fact that we have it, and it's really easy. In the backend, we use IPsec, but you don't have to really worry about IPsec keys or generating any of that stuff, because Docker takes care of it. Pick the application subnet size carefully. What I mean by that, a lot of times people leave subnets to use the default, which is /24, which means that they're limited to 254 containers per network, and sometimes they need more than that. So if you think that your application needs more than that number, you can define that when you create the network itself. Finally, designated non-overlapping subnets to be used by Docker for overlay networks. I'm going to highlight that in the next segment here. And this is a customer story. So as we work with a lot of customers, we see a lot of issues, and we want to make sure that we share those with you so you don't fall into the same problem. So imagine here that we have an actual service within your underlay network that is at 10, 10, 10, 100, right? And imagine that you left your overlay, that you created your overlay, and it used randomly at the default 10, 10, 10, .0/24, right? If your container is trying to reach the actual underlay-based server, Docker will not understand that, right? Because it falls under the same subnet, and it would think that it is actually part of it's a different service on the same overlay within the Docker cluster. That means it's going to be black holing the traffic. So what we recommend is to do the following. When you create network, make sure that you define the subnet. And before you define a subnet, make sure that you work with the networking team. Designate one or two subnets that they don't use, right? And you can use them over and over again within your Docker cluster. So this is about a recommended best practice, so you don't fall into the problem where you have blackhauling happen because you think that Docker thinks that you're trying to reach something within its network, while it's actually a service that's in your underlay infrastructure-based network. So it was due to improper network subnet design. We have overlapping subnets, and the recommendation is dedicate subnets from the underlay to be used by Docker. Let's talk about storage real quick. Most of our customers use, a lot of our customers use CentOS, Red Hat. A lot of them use Ubuntu. So specifically for CentOS and Red Hat, make sure that there's specific production-ready configuration for device mapper that you have to go through. We make it a lot easier if you go through the docs. We created some tools to make it a lot easier to configure it for production settings. That's one of the #1 issues that a lot of our customers have today with storage backend for the engine itself. For DTR storage, this is where you store your images. Make sure that you have a replicated and secure DTR storage backend. And finally, for the application layer, we have Docker Store, and we have a lot of storage plugins that our partner ecosystem provides. So make sure that when you select one, it's one of the certified, supported data layer storage solution out there. For logging and monitoring, just as for logging, we typically see and we recommend having, even before you even install your application or deploy your applications, make sure that you have a logging solution in place. Make sure that you have a monitoring solution in place. You don't want to do that after the fact that you install even UCP and DTR. You don't want to do that after the fact that you deploy your applications, because you will need to have a centralized place to find your logs and find your, be able to monitor the complete solution. So use an external centralized logging for engine and application container logs. Please understand the difference between engine level logs, so this is related to the system, containers coming up and going down, versus the application level logs, which are the PID1 logs for all your containers. A lot of times what we need is having both centralized, so you ship your logs to an external centralized logging solution, and have something that is local, right? So local logging for active troubleshooting. And to be able to achieve that, you need to use one of the two drivers, JSON or journald. Otherwise, if you use something else, that means it's going to ship all the logs, and you're not going to have a local copy of the log entries on the engine itself. Something to be aware of. Host level and container level resource monitor. That of itself is a whole subject, but make sure that you understand what's going on in your infrastructure from a CPU, memory, networking, monitoring at the container level and at the host level. DTR image backend storage monitoring, that's another, we had a lot of issues with some customers because they don't monitor the backend storage. Monitor the engine storage as well, and use the built-in application health checking functionality. So anyone heard about the health check functionality within the engine? So you define that in the Docker file, or you can define that when you run your application at runtime. You can define what the health check is, and the engine itself does do the health check, and based on that, it would take the orchestration policy that you defined to address any issues. So this is another customer story. They deployed DTR, and they used NFS, and NFS team was a separate storage team, and they did not like each other. So it was really bad. They never really talked to each other, and all of a sudden, they were having some, in production, having some DTR issues. And the reason of that was NFS storage was really filling up, and it kind of crashed DTR because of that. And our recommendation is to monitor the storage backend. So they were not monitoring the storage backend, and they were not enabling garbage collection. So if you have those two, at some point your NFS storage is going to fill up, and at that point it's not going to be pleasant to kind of restore what you had working. So please make sure that you are monitoring the storage backend and you have enabled garbage collection. Integration. So this is how your cluster integrates with other systems. It's really critical. Docker is part of the ecosystem, and there's a lot of tools out there that provide really good integration points with Docker or vice versa. So first of all, make sure that UCP and DTR are well integrated together, right? We have a single authentication service across the two between UCP and DTR. That means that you have SSO, and that means that you have to have those two working together. By default, they work together. Just make sure that SSO is working as expected. I'm not going to go through the whole list, but we worked with customers on CI tooling, with Jenkins and Bamboo and all the other partners. The developing tooling, like making sure that you have your dev machines ready to work with the platform. IDEs, there's plenty of work around IDEs and plugins that work directly with Docker EE, with UCP and DTR. Configuration automation tools, resource provisioning systems. So if you already have something that you use today to provision the cluster, adding in the integration point, whether that is the joining process, the leaving process, defining those policies, defining those configuration is really critical. If you already have something like a change management system, I've worked with a lot of customers that have to have some type of auditing. Make sure that you have that in place. Internal versus external DNS services. We talked about kind of the internal service discovery within the cluster, but you need some integration point with the DNS service that is outside the cluster. Load balancing and incident ticketing management system. A lot of our customers actually end up having a small support team for all this, or they have like an IT team that supports this system across other systems. So they integrate the Docker solution with their own existing ticketing system like ServiceNow. That way they know how to handle those issues if they come up. Disaster recovery. I think this is one of the most critical things. A lot of people don't think about those things when they architect or design the cluster. Make sure that you have a weekly backup for UCP, DTR, and Swarm, and they're separate, right? And in the documentation that I'll share with you, defines each procedure for each. Make sure that you understand the difference of the backup policies for each, and do that on at least on a weekly basis. For the platform itself, for any upgrades and downgrades, right? Go through that process before you put any production application, right? Because things are going to happen. You're going to have to upgrade at some point. And because it's a stack that composed of the OS, you have Docker, you have UCP, you have DTR, you have your application. It's really important to kind of see what's the best procedure for your environment, document that, try to automate it if you can, and know that if things don't go the way that they should be, you know what to do to address that. So another customer story. We started putting, I don't know if you use an EE, we started putting those banners like, hey, you haven't backed up your system for so long, please back it up. Because a lot of people get excited with the product and they forget to back it up, and things happen, right? Things crash and they don't have any recovery methods. So make sure that across Swarm, UCP, DTR, and the DTR storage, each individual layer, you have a backup and restoration procedure, right? We have well-documented procedures. We have tooling around it that I'll share with you later for each individual component here. So there were no backups since installation. There were some issues, and the recommendation is to do frequent backups and tested the restore procedure before it actually happens. Finally, speaking of testing, I think it's really important to test things before you take things into production. We're not talking about the application itself, we're still talking about the platform here. Make sure that your users can log in. Make sure that your users can do multi-platform image pulls. Make sure that the setup, the design for your RBAC has been confirmed to be working so that your teams are not they're not stepping on each other's toes, or there isn't any security issues, any multi-tenancy issues with your cluster. Ensure that, I think one of the most important ones here is to confirm the application resource limitation works as expected. With Docker, you can specify the CPU and memory limitation and kind of the limit that you set for each application to use from the available cluster resources. Make sure that that's what you plan for actually works as expected. It's really important to do that. So I went through that really fast, so I do apologize. I only have like 30 minutes. One of the I work in Docker customer success team, right? And our goal is to make sure that you're successful. So we're launching a Docker Success Center. So you can go to success.docker.com, where we have a lot of reference architectures, solutions, best practices that we want you to learn from, because they're based mostly on other customers going through this same exercise, and we learned also by working with them. Things that you can see there are like complete Docker EE cluster upgrade, end-to-end security best practices, troubleshooting guides, and hundreds of technical assets. So that's a good resource to keep in mind when you're designing the platform. 3 key takeaways. Define a readiness checklist for an accelerated, smooth, and successful path to production. We understand that the platform is not trivial to take to production from one day, right? We recommend having something like a checklist where it's repeatable. You have a repeatable methodology where you can take clusters, and you're going to have multiple clusters to production, right? Making sure that you have the standard procedure that's something like a checklist. Defining that will make it easier to go to production. Will make the process very repeatable as you go on from dev all the way to production. Design the Docker Enterprise Platform based on recommendation architecture. As I said, we want your success. This is what our goal is at Docker. So work with us, right? Leverage the resources that we provide so that you're successful. Deliver to differentiate. Just remember, you want to be that bunny who's way ahead of their competition. You want to be that enterprise that's doing things, that's delivering the applications, that's taking applications to production faster than your competition. It truly translates to that at the end of the day. Your work translates to staying competitive and delivering value. Just to wrap it up, make sure that you sign up. We have if you've never used Docker EE, right, and you would like to take it for a spin, sign up for Docker EE hosted demo, and also the Kubernetes beta that we launched today. For the demos, docker.com/trial, and for Kubernetes is docker.com/Kubernetes. We have some time for questions, but other than that, hopefully this was helpful. Thank you guys for coming in. Yep. You want to use the mic? Or is there a mic? No.
Just a quick question about the logging drivers. You were suggesting to use both local logging and to have some centralized one.
Yep.
So is it possible to use multiple logging drivers for a single container at the same time?
It is not possible today. The two that I mentioned, the only way you can have a local copy of the logs is to use one of the two that are mentioned today. I think there are works today to provide the capability of having both local copy of the logs as well as be able to stream it. But if you use one of the two, the JSON one that's the default one, or the journal-D, you're able to kind of ship those logs kind of to journal, and then from journal you can take them to, that's what a lot of my customers do. They ship journal along with all other logs to a centralized logging service. That's pretty much the only way you can have both today. Yep. There's a question in the back. Or
if you want to walk to the microphone, that's right next to you. That'd be great.
Thank you.
We've got 3 data centers. We run a UCP cluster in each for data center resilience. We want to use image signing in DTR, but we only have one DTR cluster spread across the 3 sites. When will that be supported?
So you have 3 UCP clusters?
Well, we have 4. Because there's one UCP cluster just to support DTR. Right. We use the same LDAP service across all 4 UCP clusters. How do we get image signing to work?
Yeah, unfortunately today we only have a one-to-one mapping between DTR and UCP. I think there works right now on making sure that at least the trust data in one DTR can be used by other UCPs. I do apologize. I don't have an answer for that today, but it's a limitation as we stand today.
When will it be fixed?
I have to work with the product management, but hopefully, next quarter or 2. I don't know. I have to work with the product manager. Yep. Thank you. If you want, maybe we can talk offline, so I can take your information and we can stay in touch.
Hi.
Hello.
Why do you recommend 16 gigabytes of RAM and 4 CPUs for manager? Because it seems a lot of resources for single manager.
Right. Great question. So, as you know, that the managers hold the key value, the raft store, right? That's in memory, right? So, as you scale up services or you add networks, as you add your applications, additional configuration, UCP itself, you're going to have more and more memory needed for that. Now, I'm not saying that 16 is a typical use for it, but that number didn't come from. It actually came from the Docker infrastructure team running Docker, so Hub and all the Docker SaaS products. We needed that much, even if they were not running any workloads, right? So that's our recommendation, so that you don't. It's actually lower than that, but we recommend 16, so that you have some room just in case as you scale your applications, because that would utilize some of that memory. So hopefully that kind of answers your question. But it's actually based on Docker applications running on Docker internally within our infrastructure. Yep.
Thank you.
Any other questions? All right. Thank you, guys.